Hello, everyone. Let's continue with the presentation. My name is Johanna Tuviala, and this is my colleague Mikko Pelto-Arvo. We are both from University of Eastern Finland, and I am starting my PhD, and Mikko is a PhD researcher. We will tell you about our field campaign this summer in Koli National Park, Finland. First, we will tell you about what is Koli National Park and what is happening there, about the park beetle situation there, and what was our aim study, and how we collected the field data, and very first result of this summer's data, and then finally what is coming next. So here are two maps of Finland. You can see there in the other map. Here you can see the data is from Finnish Forest Center, and it shows loggings because of insect damage on spruce stands. And it's only insect damage, but most of them is spruce bark beetle. And you can see that it's concentrated to southern part of Finland. And on the other map, you can see this is from the Natural Research Center Finland. Their data is pheromone trap catchy and cumulative sum over summer. And Koli National Park is there. It's quite northern location compared to where most of the park beetle damage is happening at the moment in Finland. Here is a map showing elevation, and you can see that Finland is a quite flat country, mostly. But in Eastern Finland, here there's a hill zone of Eastern Finland where hills are more common than other Finland. They are not mountains; they are still hills. And especially Koli National Park is known for its hills and a beautiful views, and is a popular recreational area. And it also has high cultural significance. It's one of Finland's national landscapes. It looks like this in the national park. You can see here a hint of what we will tell you about next. There are some dead trees in the landscape. So the park beetle outbreak, what started was heavy snow load on tree crowns in 2018. And after that, there was a warm and dry summer. And because of this, there was plenty of potential hosts for park beetle. And in 2002, there was snow damage again. The park beetles could breed more. And the national park is a non-intervention zone, so everything's happening there naturally. And since 2018, the park beetle activity has been increasing there. Yes, and it's interesting that actually Koli is in Finland the southernmost place where this heavy snow load forms, and it's because of the topography of the hills there. Now some places there look like this. The bark beetle damage spots are they are like, here and there. It's not vast mortality over the whole landscape, but still they are like small spots here and there. So we were interested to model the host selection over the national park area based on environmental factors, and also observe the tree ecophysiology there. And this is our setup for this summer. We have damage plots. It's brown spots where we could find good damage spots. We established the plot. It's a circular plot of 10-meter radius, and every tree on the plot is inspected for the tree characteristics and also for the bark beetle symptoms. So we evaluated the amount of holes on the tree and the amount of resin flow and the bark condition, and also for the crown, the color of the crown, and how defoliated the crown is. And we observed these during the whole summer every 2 weeks, so we could see the situation develop. And then we have also control plots on healthy stands. We have 30 dendrometers on 5-foot plots to measure the tree growth, the radial growth, and how bark beetle infestation affects the tree growth. And then we created transects, like 4 or 2 transects, which cover the elevation variability of the hills. There are soil moisture loggers and temperature loggers on the tree. And the soil moisture loggers are in the soil, of course. And yeah, this is this study was made by Emma, who is here, by FGI team. They use our ground truth data. It was already the last year data. And they created a model to observe the dead trees in the landscape with multispectral imagery and deep learning models. And this map is created from this summer multispectral photos to see how the situation looked in June. So there are all dead trees on the map from June. This airship, there is the how the imagery was collected. The sensor is installed on this Kello airship. Okay, here is still the plot setup of dendrometer and the soil moisture logger and bark temperature logger. Okay, then I will hand this to Mikko.
Okay, thank you. So here on the picture, we see the upper graph is the temperature on the summer, and it was quite normal for Finland with a small exception. So there was a quite long warm period at the end of the May and beginning of the June. So, well, bark beetles that came from the overwintering site, they loved it. So you can see from the down there is a graph at the same time what was the bark beetle population encountered in the landscape area, not in the national park. I didn't have permission to have pheromone traps there, but bark beetles were swarming at the same time that it was warm, actually. So we also had the first generation on the when the June turned to July. So it was, well, it's not that late or early, but for the Koli area, it's usually a little bit later. So this warmth promoted that the first generation became a little bit earlier than normal. But as you can then see from the rest of the year, we did not have the second generation swarming. It's still very rare even in the southern Finland. And so now for the results themselves, they are quite preliminary. We hope to tell you a captivating story since we have only less than a week time to have actual data downloaded from the devices and from this to get the analysis done. But first, here is one example of the soil moisture situation here. So we encountered 2 periods during the summer when the trees were suffering from drought, of course, depending on the situation of the soil conditions. So you can see from the brown or reddish brown is the soil moisture here, and the soil moisture was quite good in the spring for as long as the melting water sufficed. So there was quite a lot of snow in the winter, and the trees had quite good water conditions in the early summer. But then you can see that at the end of the June, this stopped, and before the next rain came, many of the trees were actually suffering from the drought. And of course, when you think of the previous slide, when the bark beetles were also on the move during the June, of course, they did find, at the end of the June, they did find very susceptible trees, and the trees they already had attacked before that, they were starting to suffer from this drought. And the second period of drought became in the very end of the summer, but of course, bark beetles had already left the trees, so it was not that important in comparison. So here is, for the beginning, here is the healthy tree. So the upper graph here is the soil moisture on the same site, and the below graph is the dendrometer data of the radial growth in the tree. So this is southwestern slope, about 240 meters above sea level. So in the sense of Koli Hill, it's not that high, but it's already on the hill side. And you can see from here that actually there is a quite good water table for the whole summer. You can see that rain, every time there is a rain, there is a spike in the upper graph, but the soil moisture remains quite balanced. But also on the lower graph here on the radial growth, you can see that there is this growth beginning from the late May and ending in the July, when the July turns to August. That's quite normal in Finland when the photoperiodic period, the amount of light starts to limit the growth. So this is what we usually see, that there are hundreds of micrometers of growth in a normal tree. Then we go a little bit further up to the hill, 270 meters. And in this case, you start to notice that, of course, in the beginning of the summer, at the May, early June, you have still quite good water table. But then you start to see that there is very great fluctuation. You can see very clear spikes on the graph. So basically, now we are more limited by the water that comes from the rain. So this tree here is actually, from which you can see from the down, is suffering from the desiccation between every single rainy period. You can see that this tree started to grow on the May, early June, but then when the first desiccation came, there you can see that there are quite much fluctuation. The tree actually starts to shrink each time there has been water deficiency. And you can see that these every rain event is visible from the soil moisture data. So this tree, luckily, for some reason, avoided the bark beetle infestation, and that's basically the reason it was still alive for the end of this period. But as you can see, it basically did not grow at all during the whole summer. Then we have this last one here, last example, 222 meters above the sea level. It's already almost on the top of the Koli Hill, and as you can see, there was quite a good moisture balance in the early summer in this case. There was quite a lot of snow during the summer, during the winter, and this melting snow, that it was sufficient for a very long time. But unfortunately for this position, the rainwater was not sufficient to support the tree for the whole summer. So here on you can see the same radial growth graph on the below here. The first signs of attack were detected on the May already. And this tree, it attempted to grow with the help of this melting water, but unfortunately it was not sufficient. We can already see this yellow arrow here when the tree, the first discoloration was detected, and it did not take more than a week when we already saw that the needles were starting to turn reddish. And this tree perished quite quickly, and as you can see, there is zero growth, and this the fluctuation variation in the growth is actually cause of the shrinkage of the trunk due to and the heat caused shrinkage and growth in this case. So when the water is the limiting factor, the tree becomes less responsive. So these two trees have quite similar water table for the summer, but this tree, which did not have spruce bark beetle, did have fluctuation. It did react with rainwater, while this tree, which had bark beetle infestation, it could no longer use the water. It started to perish. So we can actually see from the dendrometer data the radial growth when there is a bark beetle infestation. And if you would look at this same data for a little bit longer, we would actually start to see that during winter, this same tree would start to shrink due to the fact that it starts to dry and lose the volume. And finally, for the few analyses we made, they were flagged significant while the correlation was not that strong. So worth mentioning. Of course, this was no surprise that there was positive correlation. So in higher elevations, the attack score, the damage we inspected in trees was higher. So there was positive correlation between elevation and the attack score. What was more surprising was this slight negative correlation between the slope steepness and the visual attack score, meaning that the more steep the hill, the less attacks we saw in our data. And this is now probably a cause of this snow melting in the spring. So as you remember, the water table was good during the late May, early June, when the bark beetles were also active. And in this case, when this slope was a little bit more steep, there was more water flowing down the hill for as long as there was a melting snow. So in our study, it's actually showing that for as long as we have normal winter, we have snow. In that case, we also this hill side of the not up the top of the hill and not bottom of the hill, but actually these trees on the slope, they had quite good water balance in the area. But now that arises a very good question: what happens when we have a climate change? If we have less snow, will we actually see a great amount of dying trees in the middle of the hill in the future when we have less melting snow, when we have worse water balance due to the warmer winter, less snow? So these are preliminary results, but these seems quite worrying at the moment. If we actually, now we have the dead trees on the top of the hill, and we might soon encounter more dead trees on the lower parts of the hill. So the next steps would be to compile all this information we already have, make more deeper analysis, and get the more out of this data than these preliminary results. And after that, we will work with our collaborators to see if we can have something out of the ground truth data for the remote sensing application and multispectral imaging. So that would be all. Thank you.